Today, we explore how raw wood is transformed into perfectly shaped decorative spheres through precision craftsmanship and modern machinery. From selecting timber and cutting planks to turning, sanding, and finishing, this process reveals how natural materials become smooth, balanced wooden spheres ready for design, decor, and functional use. The journey begins with imperfect wooden blocks, rough edges, uneven surfaces, and natural variations that make every piece unique. Placed on the work table, each block is rotated by hand, revealing its irregular form and unpredictable balance. No two pieces are identical, and within these raw shapes lies the potential to become something precise, symmetrical, and refined. The wooden block is secured onto the lathe, held firmly along its central axis. As the machine begins to rotate, sharp edges blur into motion, and the rigid geometry starts to soften. Cutting tools make first contact with the spinning surface, shaving away thin layers of wood. With each pass, corners disappear, curves emerge, and the rough block gradually transforms into a balanced spherical form. The process now shifts from cutting tools to sanding, where abrasive layers move from coarse to fine, and finally, to ultra-fine precision. Hands rotate the sphere steadily, never pausing, ensuring even contact across the entire surface. Under close-up view, the wood grain becomes continuous and flawless. No edges, no ridges. Only a smooth, uninterrupted curvature that defines a perfect sphere. The finished wooden sphere is placed onto a flat surface, free from any supports or fixtures. With a gentle push, it begins to roll, effortlessly moving in every direction without resistance or wobble. There is no front, no back, no defined orientation, only symmetry. What began as an imperfect block has become a form governed purely by balance, geometry, and precision. Unlike the sphere, where edges are removed to achieve perfect symmetry, this process begins with wood meant to preserve its geometry. Solid blocks are positioned and measured carefully, their flat faces and sharp corners becoming the foundation for precision machining. Here, the goal is not to eliminate structure, but to define it, transforming raw material into clean, exact cubic forms through controlled CNC cutting. The CNC machine operates across multiple axes, with cutting tools moving precisely along X, Y, and Z coordinates. Each pass creates perfectly straight edges, defining sharp corners and uniform dimensions with mechanical accuracy. One by one, identical cubic blocks separate from the larger material, forming a series of shapes that appear almost indistinguishable. From a wide view, the repetition becomes striking, geometry replicated with exact consistency. A precision square is placed against the corner, confirming the 90-degree alignment between surfaces. Two cubes are pressed together, their faces meeting seamlessly with no visible gap or misalignment. Edges remain sharp and clearly defined, with no rounding or distortion, evidence of accurate machining and controlled finishing. The geometry is not only visible, but measurable. Finished cubic blocks are stacked in precise alignment, forming orderly layers of uniform geometry. They move forward into assembly lines, no longer individual objects, but standardized components ready for integration. These shapes will become modules, frames, and structural elements, small units contributing to larger engineered systems. From raw wood to functional architecture, precision now enables connection. Beyond the precision-cut cubes, the journey of wood continues in another direction. Here, the material returns to its earlier form. Logs, branches, and rough sections gathered from forest yards. These raw timber pieces, still carrying natural irregularities, now approach the factory gates. Before transformation into engineered boards, this is the moment where nature meets industrial preparation once again. Once inside the facility, raw logs enter the first stage of industrial transformation. They are measured, aligned, and fed into debarking machines, where rough outer bark is stripped away to expose clean wood surfaces beneath. The debarked logs then move forward into powerful chipping systems, breaking solid timber into uniform wood chips. This conversion from large natural forms into controlled particle size creates the essential starting material for MDF board production. At this stage, the freshly produced wood chips undergo cleaning and conditioning to ensure consistency and quality. Impurities such as bark fragments, dust, and oversized particles are separated through screening and air classification systems. Moisture levels are then carefully adjusted, stabilizing the chips for uniform processing in later stages. By the end of this phase, the material has transformed from raw fragments into clean, in-spec chips, ready for precise fiber production. Here, conditioned wood chips are transformed into fibers through mechanical refining under heat and pressure. The chips soften, separate, and unravel into wet fibers, forming the fundamental structure of future MDF boards. These fibers are then rapidly dried using controlled hot air systems, reducing moisture while preserving flexibility and bonding potential. By the end of this stage, the material has evolved from solid chips into lightweight, dry fibers, ready for resin blending and mat formation. At this stage, the dried wood fibers enter a blending system where resin binders and additives are evenly applied. Each fiber becomes coated, creating the chemical bonds necessary for strength, stability, and durability in the final board. The treated fibers are then distributed into a uniform layer, forming a loose fiber mat. Through controlled pre-pressing, the mat gains initial density and cohesion, transforming from soft fibers into a structured sheet ready for hot pressing. Here, the pre-pressed fiber mat enters the hot press, where heat and pressure activate the resin and permanently bond the fibers together. Within minutes, the loose structure transforms into a dense, rigid MDF board with controlled thickness and strength. After pressing, the boards move through a cooling stage to stabilize internal stresses, ensuring dimensional accuracy and preventing warping before further finishing.
The transcription for this video is empty, as the user explicitly requested no voice in the prompt.
In the final stage, cooled MDF boards are trimmed to precise dimensions and sanded to achieve a smooth, uniform surface. Quality control systems inspect thickness, density, and structural integrity to ensure each panel meets industrial standards. Once approved, the finished boards are stacked, palletized, and securely packaged, ready for storage, transport, and integration in a furniture and construction application program.